Greetings, everyone. This is Norman Stevens, your friendly economics teacher. For Economics 103, we're going to look at Chapter 7, Government Actions and Markets. We'll look at the chapter checkpoints questions and also the answers. Typically, in an on-ground class, we'd examine these questions in class, and then students could work on the questions either individually or in groups, and we'd review the answers and the methods to solve the answers. So what you might do for this exercise is to answer the questions on your own, then listen to this Camtasia recording and see how your answers match to my answers. Let's begin. The table on the right here shows the demand and supply schedules for on-campus housing. Use the table to work problems 1 to 3. Table's produced here. First question asks, if the college puts a rent ceiling on rooms of $650, what is the rent? How many rooms are rented? And is the on-campus housing market efficient? The first thing to check when you look at these problems is what's the equilibrium price? And at 600, you can see where the quantity demanded matches the quantity supplied, so you know the equilibrium rent is $600 a month. Now the college is planning to put a rent ceiling on rooms at $650 a month, which is above the equilibrium rent. You might be suspicious right from the start. The equilibrium rent is $600 a month, and the equilibrium quantity of rooms is 2,000 rooms. The rent ceiling of $650 a month is above the equilibrium rent and does not change the market equilibrium. The rent remains the equilibrium rent of $600 a month. The quantity of rooms rented remains 2,000 rooms, and the market remains efficient. And again, this is a rent ceiling being placed at $650 a month above the equilibrium rent of $600, so there's no effect. If the rent ceiling were placed below the equilibrium rent, there would be some effect. And in fact, question 2 has that very scenario. If the college puts a strictly enforced rent ceiling on rooms of $550 a month, what is the rent? How many rooms are rented? And is the on-campus housing market efficient? Explain why or why not. You can look at $550 a month, what the effect is at that rate. Quantity demanded is 2,250. Quantity supplied is 2,000. That's a problem. The rent ceiling of $550 a month is below the equilibrium rent, so the rent is $550 a month. At this rent, 225,000 rooms are demanded, and the quantity supplied is only 2,000 rooms. So 2,000 rooms are rented. The on-campus housing market is efficient because the supply is perfectly inelastic, so the quantity remains equal to the efficient quantity. However, there is a shortage of rooms, and students spend additional time searching for housing. Shortage of rooms since there's a 250 room difference between what is demanded and what is supplied. What's next likely is a black market scenario. And question 3 states that very option. Suppose that with strictly enforced rent ceiling on rooms of $550 a month, a black market develops. How high could the black market rent be, and would the on-campus housing market be fair? Explain your answer. Well, the black market rent could be as high as $600 a month. That is the equilibrium price, which is the maximum rent someone is willing to pay for the 2,000th room. If a black market develops using the fair results approach, the market is not fair because the poorest students cannot find the higher black market rent. Using the fair rules approach, the market is not fair because the rent ceiling blocks some voluntary exchanges unless the buyers and sellers are willing to participate in the black market. Questions 4 through 6 ask you to look at the table reproduced here on the right, showing the wage rate, dollars per hour, quantity demanded of student workers, and the quantity supplied. If the college introduces a minimum wage of $10.50 an hour, how many students are employed at on-campus venues and how many are unemployed? Again, for these questions, you can quickly scan and look at what the equilibrium wage rate is of $11. And now there's a minimum wage of $10.50 an hour. Well, this is similar to problem 1. Equilibrium wage rate is $11 an hour and 400 workers are employed. If the minimum wage is set at $10.50 an hour, the minimum wage is below the equilibrium wage rate. So the minimum wage does not affect the market equilibrium. The wage rate remains $11 an hour, 400 student workers are employed, and no student workers are unemployed. There would be a difference if the wage rate were higher than $11 an hour. If the minimum wage, say, were raised to $11.50, $12, then you'd see some effect. And question 5 then states, if the college introduces a strictly enforced minimum wage of $11.50 an hour, how many students are employed, how many are unemployed, and what is the lowest wage at which some students would be willing to work? You can look at the chart here and see the numbers at $11.50, the quantity demanded of student workers at 300, quantity supplied, meaning that there's 450 workers willing to work at that wage rate of $11.50. So if the minimum wage is set to $11.50 an hour, the minimum wage is above the equilibrium wage rate, so the minimum wage has an impact. The wage rate is $11.50 an hour, and 300 student workers are employed. At $11.50 an hour, the quantity of labor supplied is 450 student workers. The quantity demanded is 300 student workers, so 150 student workers are unemployed. Some workers are willing to work for $10 an hour. Whereas if you come back up to the chart, it does show that there's 300 workers willing to work for $10 an hour. Question 6. If the college introduces a strictly enforced minimum wage of $11.50 an hour, who gains and who loses from the minimum wage? And is the campus labor market efficient or fair? So the workers who retain their jobs and are paid the higher wage rate gain from the minimum wage. They have jobs at that higher wage rate. The employer, the workers who lose their jobs, and workers who must undertake extensive search for a job lose from the minimum wage. The minimum wage of $11.50 an hour is not efficient. There is a surplus of workers, and the marginal benefit to firms exceeds the marginal cost to workers. There is a dead weight loss. The minimum wage is unfair under the fair results approach because some student workers lose their job. The minimum wage is unfair under the fair rules approach because it blocks voluntary exchange. Questions 7 and 8, we'll use this chart that's reproduced here, showing the price per pound of mushrooms, quantity demanded, quantity supplied. Suppose the government introduces a price support for mushrooms of $4 per pound. What are the quantity of mushrooms produced, the surplus of mushrooms, and the dead weight loss created? When you first examine these questions, you can simply look at what the equilibrium price is. The equilibrium price is already $4 per pound. Quantity demanded of 3,500 matches the quantity supplied. So you know that right away before you then analyze the question. And these questions follow a pattern. Question 1, question 4 are asking about some sort of government control that's below the equilibrium price. So there is no real effect where it's at the equilibrium price, no effect. The equilibrium price is $4 a pound, and the equilibrium quantity is 3,500 pounds a week. With a price support of $4 per pound, 3,500 pounds per week are produced, and the surplus is 0. Because the price support equals the equilibrium price, neither the price nor the quantity changes. There is no dead weight loss. There is really 0 effect of having a price support at the equilibrium price. It's meaningless. Change it around though. Suppose the government introduces a price support for mushrooms of $6 per pound. Who gains and who loses? What are the quantity of mushrooms produced, the surplus of mushrooms, and the dead weight loss? And for this kind of a question, it's best just to draw a graph so you can see in your mind a bit clear what's being referred to. So this graph is shown here. Equilibrium price of $4 a pound, quantity of 3,500. Now the government's introducing a price support at $6 a pound. So the support price is up here. And you can see then at that price, then 4,500 pounds of mushrooms will be supplied, and the surplus will be shown here. Explain that a little bit more in just a minute. So if the government introduces a price support of $6 per pound, production rises to 4,500 pounds per week. In other words, at that price, the producers will say, sure, we'll produce this many mushrooms, this many thousands of pounds of mushrooms at that price. The mushroom producers gain from the price support. Mushroom consumers and taxpayers lose from the price support. There is a surplus of 2,000 pounds per week, and that's shown here, where there's the 4,500 pounds produced right here at the supply point. The demand point is over here at 2,500 pounds. That means people are only willing to buy 2,500 pounds of mushrooms, so a difference of 2,000 pounds of mushrooms at that price. And then you can use the figure to calculate the deadweight loss, which is this gray triangle here. The deadweight loss is the area of the darkened triangle. We know the area of the triangle could be 1/2 the base times the height. So in this case here, the height you can determine of $2 down here and $6 here. So $6 minus $2 is 4. So this height here will be 4, and then this distance here is 4,500 minus 3,500, or 1,000. So it's going to be 1/2 times 1,000 pounds times $4 a pound, which is $2,000. Deadweight loss of $2,000. Use the following news clip to work problems 9 and 10. There's the newspaper headline, coal shortage at China plants. Actually, it's a CNN headline, cable news network. The government of China has set price controls on coal and gasoline in an attempt to shield poor urban families and farmers from rising world energy prices. Chinese power plants have run short of coal. Sales of luxury gas-guzzling cars have increased, and gasoline consumption has risen. Oil refiners are incurring losses and plan to cut production. Are China's price controls price floors or price ceilings? Draw a graph to illustrate the shortages of coal and gasoline created by the price controls. All right, so you can draw, here's one graph that's showing the effect of that, or it's the equilibrium price of $600 per ton of coal, 99 tons of coal, the equilibrium price. And then the government imposes a price ceiling here of $550, saying the price cannot go above this price. So China's price controls are price ceilings. The government has placed an upper limit, that is a ceiling, at which coal can be traded. In the face of increased demand, China's price controls have kept the price from rising to its equilibrium. As a result, the quantity demanded exceeds the quantity supplied, and shortages have resulted. And figure 7.2 illustrates the situation in the market for coal. The figures for gasoline would be similar. In figure 7.2, at the controlled price of $550 per ton, the quantity of coal demanded is 100 million tons per week. So here with the price ceiling here at 550, see where it intersects the demand line there, 100 million tons of coal there. The quantity of coal supplied is 97.5 million tons. Look where the price ceiling line intersects with the supply line here, 97.5 million tons per week. There's a shortage then at this distance of 2.5 million tons per week. Explain how China's price controls have changed consumer surplus, producer surplus, total surplus, and the deadweight loss in the markets for coal and gasoline. Draw a graph to illustrate your answer. So here's a graph. It's identifying different portions of the graph. I'll review all those portions. China's price controls aim to keep the price from rising to the equilibrium level. So they are examples of a price ceiling. Price ceiling, thank you. A price ceiling decreases the quantity available to the quantity supplied at the price ceiling. So the price ceiling there, it's restricting the quantity available. In figure 7.2, that was the chart above, the quantity with the price control is 97.5 million tons of coal per week. The price ceiling also increases the willingness to pay for the quantity available. That's to $675 per ton in figure 7.2. And again, that 675 is right here on the demand line. Price of 675, right in the middle between 700 and 650. And it creates an incentive to incur surge costs and trade illegally in a black market. Because the price and quantity decrease, producer surplus decreases. Because the quantity decreases and surge costs are incurred, consumer surplus decreases. And because this quantity decreases and surge costs are incurred, consumer surplus decreases. A deadweight loss arises. A deadweight loss arises. Figure 7.3, reproduced again down here, shows the changes in consumer surplus, producer surplus, and deadweight loss. With no price ceiling, that is without this price ceiling, the consumer surplus is equal to the area A plus B plus C. Why is that? Well, you take away this price ceiling here and just have your original graph of supply and demand meeting at this point of 600. The area underneath the demand line then is the consumer surplus. But now with the price ceiling, the consumer surplus is limited just to this triangle A. Why is that? Well, people are willing to pay $675 here. So at that point there, it's simply triangle A. The surge costs are sections B and E. The producer's surplus without the price ceiling is equal to the area E plus the area F and G. So E, F, and G. How is that determined? Well, without the price ceiling, producer surplus is at the equilibrium price. The area below that price line of 600 would be the producer surplus. But now there's a price ceiling. So with the price ceiling, the producer surplus is simply equal to the area of G. This tiny area here below the price line, this area G. Without the price ceiling, there is no deadweight loss. With the price ceiling, there is deadweight loss equal to the area C and F. So that is, with the price ceiling here, intersecting the supply line there, and going up to the demand line here, this combined triangle of the areas C and F would be the deadweight loss. The areas B and E are resources lost to search activity. Again, people searching for the resources, that's equal to that area, B and E. Slightly complicated graph showing the different sections, but also showing the effects of the price ceiling and the reduction on consumer surplus, producer surplus, and the resulting deadweight loss in this area. I hope that helps. Please send me an email if you have any questions.